All right. So when you guys actually do see me, you'll also find I have a really weird laptop. I do not recommend getting my laptop unless you know exactly what you're doing, which is a lot of Zoom meetings. That's why I had the laptop over for COVID. Um, so anyway, welcome. You have made it to 10:51. I apologize for any of the confusion. I know for a lot of you, this is like your first semester in college ever. So it's like, what's the difference between a lecture and a lab and all that stuff? So a couple things to note. When you signed up for this class, you signed up for one of 8 different sections. I teach 7 of them. Um, Now, what that is, and I think the last one is like an evening class or something. Um, when you signed up for this class, you signed up for 3 commitments a week, 2 lectures and 1 lab. Okay. Your lectures are Tuesday, Thursday, which means from 2 p.m. to 3:20 p.m. Okay, which is where we are right now. Next time it's going to be in person in Beery Hall. Um, your other commitment depends on which of the 7 different sections you signed up for, because uh, apparently the fire marshal gets really upset if I try to stuff 250 people into a 50 occupancy room. I mean, um, and that's just one of the people you don't piss off, the fire marshal, apparently. So we have to split up people into multiple rooms at multiple times to do that. Awesome. Thank you, David. So so overall we've got so that's what this is. That's why we have a bunch of different That's why we have a bunch of different people talking about when is lab. Oh, did I miss lab? Um, you know, oh, I see I have this and this time, but we also have lab. Your lectures are Tuesday, Thursday from 2 p.m. to 3:30 p.m. That's true for every single section for every single student. Every student who's taking 1051 will meet together at the same time in the same place. Then when you have your lab, you'll be meeting with 30 students, although one lab does have 50 students. So and that's at a different time. When in doubt, this is the TLDR. Just look at your schedule and follow that, and you're not going to be wrong. All right. So, welcome. This is CIS 1051 Intro to Problem Solving and Programming in Python. So, I am Professor Andrew Rosen. This is my email address, andrew.rosen@temple.edu. If you have any questions at all, just send me an email. Thanks to the wonders of the internet, I'm pretty much always attached to that phone. Sorry, always attached to my email, thanks to my phone. And I'm gonna just hit the top level bullet points for this course. So first off, this course is flipped essentially. It means that I've got lectures. You will be reading lectures, sorry, reading some material slash watching lectures each week before coming to the lecture sections for practical exercises. Because we have such a large class, I find that doing practical exercises, guided practical exercises, really helps. Really, really, really helps. Um, and I'll give you the grade breakdown, but you do get a credit for doing those exercises in class. The labs will be held in person unless otherwise specified. Um, the Zoom link, I've put the Zoom link, the Discord link, and a link to the lecture recordings all over here. I think I actually have to update the lecture recording link, but I typically don't do that until after I have a lecture to record. Um, they're all here, as well as on the front page of Canvas. Um, So I record my lectures. You can find them here on lecture recordings, as well as over here, right? Same link, and it brings you up to this page. Okay. And I will be modifying this today, but I've got all these are playlists of previous semesters. So if you want to get ahead somehow, then you can always look at the previous lectures from previous semesters. What each of these videos are is that they're not a video, as I explained here. It's actually an embedded playlist. So all you have to do is just simply click right over here, and there's all the lectures that it will be the list of all the lectures that we do. Okay. So let's see. I will go over that. Um, So the other big item here is, as I'll explain in more detail, is how to turn in your homework. Your homework is the lab assignments, and they have a two-part process that your lab instructor should explain. The first thing is that you do two steps. First, you submit your homework, which means you upload the appropriate files to Canvas. Your homework is judged late based on the day it was submitted, not on the date it was demoed. And then you demo your homework, which means you show it to us during the lab or during our office hours or right after class. That's how I actually give you a grade. It's the only way I can do this with this many students. Uttering some variation of the phrase, "I did not know we needed to demo our assignments to receive credit after the first exam," will be grounds for an instance F in the course for failure to read directions. Okay, that is the only way you can automatically fail this class. Do not say some variation of this word. "I didn't know we needed to demo our assignments." Fortunately, I've never had to do that for a student, but it just makes sure. Because I would get students who would essentially lie to me and say, "Oh, I didn't know I had to do this. Can we please demo? Can I please demo all my assignments at the end of the semester?" Don't do that. Okay. Again, this is the high level bullet points. I will be going over all this in more detail. This class is essentially go over the syllabus and a bit of history. You will sign up for your textbook here. Go to runestone.academy and use the course code fall 2024 Rosen. The textbook is free. I would never, when possible, I try to use free resources for my students because it seems like a slap on the face to make you pay more when you're already paying for college. This textbook is really good, by the way, like really, really, really good. Okay, so here I go ahead and log in, and there will be some textbook exercises which can get auto graded. You find it over here, textbooks. And what I love about it is that it has, let's see, where can I put that? It has embedded, let's see, next one. It has embedded embedded programs. Like over here, we've got a bit of Python code, and I can run it. And it's a graphical program, and it has no problem doing that. If you need a quick way to write a Python program, you can just hit the edit button over here. And you can just write code, which I don't expect you to know how to do yet. That's perfectly fine. I'm just showing off that I'm just doing it all in a web browser. It's a great textbook, and it's great that's free. When you do sign up, use your TU email as your sign up email, TUXX, whatever that number letter combination is, as opposed to your alias. And use your exact name as displayed on Canvas as your name. This is because I have a script at the end of the semester to merge grade books. And if you do this, this makes my job a lot easier because then I don't have to match 250 students to 250 different accounts. So if you just use this, then that's going to be great. Oh, I need to remove this because we don't do office hours sign up anymore. Don't cheat. I'm very good at catching cheaters. Pattern matching is a subdomain of computer science. I have submitted 56 academic dishonesty charges since fall 2021. Most of them have been during COVID. Don't cheat. And if you do cheat, I have a regret clause, which means that if you feel bad about it, and you can admit to it, and it won't be an academic dishonesty charge, as long as you contact me first. I'll get into that in more detail, but don't cheat, please. If you're having trouble, come to me for help. That's my job. Don't come to class if you're feeling sick, even on exam days. I'll work with you to help make it so that you can make it up. Okay. And finally, demoing all your assignments at the end of the semester has never worked. So I'm just gonna say no now. So what is this course? Now that I've gone over the kind of top level stuff. This course is Intro to Programming. This is for both majors and non-majors. So we have a lot of computer science majors in this class. We have a lot of non-computer science majors in this class. We have a lot of freshmen. We have a lot of not freshmen. So we have a lot of students who this will be their first, this is the first step in what they already know is going to be a degree in computer science. There's a lot of students here also trying out computer science for the first time to see if they like it. A lot of people who probably have no interest in doing a full career of it, but they know that programming is good to know, so they're taking a course in it. And a lot of people who are in engineering and just want to, or biology and want to add a bit extra to the resume. So all skill levels. Um, some people have a lot of background in computer science. Some people, and a lot of you have no background. And this course, the entire point of it is to make it engaging for all of you. Um, so just a heads up though, this is a 4 credit hour course, which means that you are expected to spend 8 to 12 hours on coursework each week outside of the lecture. That is about the metric is somewhere between 2 to 4 hours for every credit hour, right? So it's about 8 to 12 for this one, depending on how you count that lab hour. This is a skill-based course, and so the only way you can improve your skills is by practicing. And falling behind means, well, there's a time deficit you have to make up, and that's hard. Okay. So Tuesday and Thursday is 2 p.m. to 3:20 p.m. Bury Hall 160. Courses may be held over Zoom if necessary due to illness or other factors. So, and here's a list of all the labs. So while all students share the same lecture, every student will be in one of several different labs. In your lab, when you sign up for the course, you'll sign up for 1051.001 or 1051.002 or 1051.003. That 3-digit number, the 00 whatever, that's your section. Okay. So if you want to know who your TA is, figure out what your section is, and then come down here and I've got a list of all the TAs, when their office hours are, and where their office hours are. A lot of them are doing their office hours over Zoom. Okay. And this information is duplicated here, but that's essentially the same information on your syllabus. Okay. So now let's go ahead and see. We've got prerequisites. You need to have a C in 1021 or higher, unless they've changed it. You are also expected to know to how to use a computer. Technology requirements. A reliable laptop is strongly recommended, especially since we're using an online text. I need to emphasize this point, reliable. I have written in great detail about this. So emphasis. If using your laptop or computer is a painful experience where it takes forever to do anything, you will suffer physically, emotionally, mentally, and academically in this class. Please read the last point about suffering. You will also experience torment, lamentations, wailing, gnashing of teeth, any other biblical terms that you can think of. Programming's hard enough when you're trying to fight when you're not fighting the computer physically. And if it's like got a cracked screen and it takes forever to load, ugh. A new computer is approximately one that will get you through your entire college career, believe it or not, will be about $400. Low power computers are great these days. And if you need help finding a computer, I will help find one in your price point. But you can always borrow laptops for multiple hours from many of the kiosks on campus. Okay. This was all for when all we did. Can you use a MacBook for this class? Yes. Yes, of course you can use a MacBook. You'll find that about 50% of the students do use MacBooks, and about 50% of the students will use Windows, and then there will be one or two of us who decide, I want to be different, and I'm going to use Linux. I was certainly that person. So, all right. So I've already mentioned what the resource for the textbook is. Go to runestone.academy to sign up for the textbook. Enter fall 2024 Rosen. And you'll be able to access this. This will enable you to essentially do a lot of this, the in-class exercises. But the in-class exercises as well as the solo exercises. If you need additional reference, specifically, there's some people who some people will have constraints, and hard back textbook is better for them. Al Swiegert's Automate the Boring Stuff with Python, which I will be using a chapter from later on in the semester, is a really good book. Also free. but also a hard copy's between 20 or $30, which is a good price for a textbook, right? And then Alan Downey's Think Python: How to Think Like a Computer Scientist, also available for 20 to $30. These are not required. These are just simply, I need another way to look at this kind of kind of solution. And again, the textbooks are available for free. This is the only required textbook. These are good other references that you can buy hard copies for if you wanted to. And then Python has its own documentation. Office hours. So these are the times that professors set aside to meet with their students to help with the course or discuss various topics. I need a modified to list when my office hours are going to be, but my office hours are, I plan on making my office hours from 7 p.m. on Tuesday, so today, and to 8 p.m. That'll be over Zoom. And then before class on Thursday, which would be 12:30 to 1:30 on Thursday. If you cannot meet me during that time, th- then send me an email. Those hours are just simply hours that I am setting aside to say, this is when students are going to be my priority and they can just drop in. Okay. The other, but I'm still available any other time. I can do Zoom or other video chat with you late, pretty late in the evening if I need to. Okay. Um, Also, your TAs have office hours, all of them. And you don't have to, there's a lot of different TAs. You are allowed to go to any TA in the course. We've got 8 TAs. We've got 8 TAs in this course. You are allowed to go to any of them for help. Sorry, 7 TAs. One of them's listed twice. Okay. All right. Peer tutoring, free peer tutoring for all of our computer science classes is available for free in Circ 358. That's the same building where I have my office. So attendance is expected for your lectures and your labs. If you show up late, I get it. It happens. Um, Lectures, I tend to cover, things, including questions that will be on the exam. So, it's a good idea to come to the lecture. That being said, I do record these and upload them to YouTube, not because I'm trying to get that sweet ad money. I don't. I've completely turned off any kind of monetization on my channel. Um, but because I know that YouTube is basically the most reliable video service out there, if I throw it on YouTube, it's not going to be my fault if somebody can't access it. Um, so again, but like, attendance is expected. We don't take attendance. It would take too long. And you're adults. If you have something else you need to do, you have something else you need to do. But attendance is expected. Okay. Illness. If you are or suspect you're sick, don't come to class. Just do what you need to do to get healthy. Just let me know. And if you miss an exam, let me know as soon as possible so we can schedule a makeup exam. We need to get that done within a week. Um, you know, Again, if you're sick and you have to miss a regular lecture though, just catch up on the recording. Mental health. So if you experience significant stress, worry, changes in mood, or problems eating or sleeping this semester, whether because of this course or other courses or other factors, please do not hesitate to reach out to me at any hour to me. Okay. I may not be able to, magically wave a wand and solve all your issues, but talking about issues can sometimes help. And I can definitely get you in contact with the right resources on campus. Okay. Um, it's also important to let me know if there's external factors such as housing that are, you know, preventing you from getting your work done in the timely manner. Um, and and large issues cropping up. Um, it's better to tell me about those things sooner rather than later. The sooner you tell me about any kind of difficulties with the semester, then the more power I have to adjust, the more power I have to help. The wrong time to tell me is the week before the semester ends. At that point, I don't my ability to help is limited, and there's no way to make up all the work all at once at the end. And it's reflected in the grades on the final exams. Um, if you have a disability or need some other kind of accommodation, contact Disability Resources and Services. Um, I've already signed multiple students, for accommodations. I will work through DRS to figure out what reasonable accommodations are. I've yet to find an unreasonable accommodation. Okay. As I mentioned, I record my lectures. Once again, here they are. Go home, go to the front page of our Canvas page. You can find it here on lecture recordings, or you can find it here. There's also a direct link to my YouTube channel. It's fairly unorganized there, though, but you're more than welcome to sift through that. Again, I have it on YouTube not because I'm trying to monetize anything, but because I know that you will be able to access YouTube. Okay. You're allowed to make your own recordings of the lecture, but you need to tell me. Mm. The official school policy is that you can record with the instructor's permission, but only for personal use. Okay, so grading in this course. So letter grades are assigned at so yes, there will be a curve, but it only helps you. You're guaranteed if you get a 90 or better, you're guaranteed to get an A. If you get a B or better, sorry, if you get an 80 or better, you're guaranteed a B. And I do mean an A, not an A minus. And I do mean a B and not B minus. Okay. Last semester, 90 and above was, I believe 90 and above was an A, and 88 and a half to 90 was an A minus. Okay. In general, though, you need about a 70 to pass the class. Your raw score is not curved, but the grade ranges, as I kind of described, will be widened. The DFW rate, the D's, F's, and withdrawals for the class and similar classes has consistently been around 30% for large classes. That said, because of my long-standing beef with the financial aid office and them not taking my signatures or believing that I exist, they I and they're very 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 unclear or in contradictory instructions between instructors and their own internal stuff. I As long as you try, the minimum you'll earn is a D. Okay. If you drop off the face of the earth and don't turn anything in, that's an F. But D, if you try until the end, I'm happy to give you a D. Okay, your final grade in the class is determined as follows. Solo exercises are worth 10%. And I'll go into what these are in a bit. Classroom exercises, 5%. Demoed lab demo assignments, 25%. Final project, 10%. Exams, 30%. Final exam, 20%. Now, let's just quickly do a bit of math here before we even get into any of this. All this stuff is out of class stuff, non-exam stuff. This is exam stuff. Exams are half the grade. Final projects are and all this stuff is about 50%. Now, as I'll explain in a bit, there's no reason not to get 100 on these. Okay. Then this is your homework. You're essentially going to, you do it or you don't. In computer science, unfortunately, it either works or it doesn't. So as long as you're turning it in on time, that's also easy to get 100 on. The final project is easy to get a 90 or above on. You can ask a lot of the former students who've taken this class before, but the final project, it's very, as long as you make an effort on it, that'll be 90 on the final project, which is 9 out of 10 points there. Okay. So that's basically so as long as you do the work, that's basically 50 points right there. Now the exams are worth another 50 points. Now if I do the math here and I completely do terrible on all the exams and get like only 50s on them, I still pass the class as long as I do all the homework. So doing the homework is important. Of course, if you end up doing the homework, you'll probably do better than the 50s. So, so let's go into each of these categories and describe what they are. The solo exercises are the reading and exercises I assigned from our textbook. If you go to our textbook, Fall 2024 Rosen, right? When you log into this textbook, you'll come up to a page that has the assignments on it. Or you can go over here, click the person button. I'll be showing this throughout the semester, and click assignments. And it'll have these. And some of them are just simply for reading the textbook and basically checking the I read this section check mark. Like so. Right. Sometimes you have to interact with the environment as well. But that's what these are. Similarly, we have exercises over here. Like once you complete them, it will auto grade it. And a lot of these exercises are auto graded, in fact. So super easy for me to go through and grade these things. You have unlimited attempts on these, and these due dates that I have down for here, these are soft due dates. I have three types of due dates: soft, firm, and hard. Okay, these are soft due dates. This is when I expect you to have it done. As long as it's done by the end of the semester, it's going to get graded. Similarly, but these solo exercises, these are things that they're intended to be done with as little direction from me as possible. And if you do need help on them, if you find yourself spending more than 15 minutes on a single problem, hop on the Discord channel and ask for help. You can say, hey, I'm having trouble on this one. Did anybody else solve this one? Solo exercises, I'm extremely lax with. Work with other people on them. Okay. I'll go over the Discord link in just a bit. Classroom exercises. So this is 5% of the grade. These basically are anything we do in class. The defining feature is that they involve active learning, the primary focus of the lecture. The idea is that they are intended to be done start to finish in the lecture. You will not be getting none of the classroom exercises will I say, well, we didn't finish it, so finish it at home. No, what we do in the lecture, that's everything. Because most, if not all, the answers will be provided in the lecture. And you can may work with your classmates and turn in the exact same code as your classmates. Think of this one as your participation grade, if that makes any sense. Okay, that's what it is. Again, these are soft. As long as you turn in the relevant work, that's great. Your lab assignments have a firm deadline. This is 25% of your grade. It's most analogous to the homework in your other classes. You'll be getting one a week or so. The fourth week, you'll get one that says lab 4 and 5 because it's expected to span 2 weeks. But they are intended to be started and substantially worked on in the period that they're introduced. They get supervised by the professor or the TA for the introduction. And again, getting help from other students, I greatly encourage that. But most importantly, your code has to be demoed and explained to receive credit for it. The due dates for the lab assignments are firm. We have a late penalty. I have a fairly lax late penalty where it's 5 points per day late for the assignment, with a maximum penalty of 50% of the original grade. Late grades for the assignments are determined when you turn it in, not when you demo it. But the sooner you demo it, the sooner we could correct a mistake that happened due to a misunderstanding. You have up to 2 weeks. You will have up to 2 weeks after the due date to demo your lab before it becomes a 0. So let's say that the homework. So this first homework is due next Wednesday. Okay, this first homework is due next Wednesday. That means you turn it in on Wednesday. You have until not the Wednesday. So it's due Wednesday of week 2. That means you have to demo it Wednesday of week 4. But again, this can be waived. The reason I have this demo limit in there is that I've had to deal with a large number of students who wait to the end of the semester to demo all their projects that I've mentioned previously. And it's not fun to do that for anybody because it's typically not students who have been keeping up to date with class, and it's not good for anybody. Um, so simply put, if you wait to demo all your assignments at the end of the semester, I get to point here and say no. On the other hand, if you're just a week or two late and you've been coming to lab and you've been actively participating in the class, don't worry about it. So how do you demo it? First, you submit it online to Canvas. Just upload your Python file. This is so that that we can see that you've done it. We've got a timestamp for when you turned it in. Second, demo it to me or the TA. What that means is that you bring it to us, run it on your computer, um, or on a lab computer, and showing that your program works. I might ask you some questions about it, and yeah, and you'll be asked to answer some of those questions. Part of it is to put, I'm not going to grade you on the quality necessarily or how nervous you are or any of that. Part of doing that is to give you the chance to kind of work out that nervousness. Because you will be asked to explain your code to people who are judging you when you go for a job interview, which can be rather nerve-wracking. So might as well, get rid of those nerves now. Get you used to explaining your code. The other reason for this is that it's a fairly easy way for me to make sure there aren't any kind of miscommunications I may have missed, and I could quickly ask you to fix something, rather than sending you a message and telling you need to fix this, and then waiting forever for it to get fixed. If you are struggling to complete a lab assignment, please let me or a TA know so that it allows me to know whether an extension needs to be granted to the class as a whole, or do I need to review something in class, or if I need to go over the assignment in class. And I have gone over individual assignments in class and given partial solutions to them when I find enough of the class does struggle on it. Right. So, but again, I kind of have a mental framework. Okay, this many students have asked for an extension, so I should probably modify the due date. Okay. Now the final project is worth 10% of the grade. That is a hard deadline. It will be due the very last day of class because that is the latest I can do. The way this class actually works is that I pretty much finished the lecture material around week 10 or week 11. I cover all the material I need to cover for this course by week 10 or 11, but rather than get into like topics that a computer scientist might need to know and will definitely be covered in later classes like recursion or algorithmic complexity. That's not going to be useful for the other half of the class who decide, you know what, I like the programming, but I like what I'm doing with my major more. And so instead we do a final project. The primary objective for the final project is to give you a chance to learn something new that you would normally not have the chance to. As long as you're using programming, the nature of the project is entirely up to you, although I have to prove it. Yes, I'll get into that. So you may implement the project in any language you choose. I've done a lot. I get a lot of people turning in video games. I got a lot of people turning into, they turn in web pages. A number of people make web apps or phone apps. Some people make programs to help them with their day-to-day life. Some people make Discord bots. It's a lot of fun. You can utilize anything you need, anything you want, as long as I get access to the hardware and software to do it. All that we ask is that you build something of interest to you, you solve an actual problem, something to impact campus, or change the world. Strive to create something that outlives the course. That's a hard one. What's the most interesting one? That's a hard one. There's a few games I've really there. Some people have done some interesting stuff. I saw somebody who taught it. It's less about what's interesting to me. There's people. It's giving students the opportunity to do things. Like I have a student who went out and learned Max MSP to make virtual instruments, or have learned how to make a guitar plugin. That was pretty cool. One of my favorites video games was somebody who made a WarioWare solution, and the graphics were deliberately terrible, and it was amazing. Max MSP is music stuff. Um, so now the final project is not something you'll have to worry about until the end of the semester. You'll have about a month to work on it. Um, and it is and it can be a group project if you so desire. You're allowed to work in a group of one, two, or three. I'm not going to force anybody into groups. But the more people you have in your group, the higher the expectation, right? So three people, I would expect more work. So that being said, I know that some of you are averse to working with others. For others, it's good. I cap it at three because more than three, it turns out, is actually kind of it it's harder for anybody to make in it. There's at four or more, you end up having one or two people who make most of the contributions, and then you got a bunch of people not doing much. So I cap it at three. Um, now the there will be four steps: brainstorming and GitHub as part of a lab. Then you'll make a proposal. We'll have something called a proposal day where I dedicate the entire lecture. That will be done over Zoom because students will be able to leave as soon as they're done with the proposal, and I just simply meet with every group and approve their idea. Um, Next, we have the progress report, which is like a week or two before the due date, which is just simply saying, do you need to update any of your idea based off of what you've learned? And then the final project. The final project and all of its part must be uploaded and worked on using GitHub, which I will teach you how to do. Failure to do so is an automatic zero. But this is just simply so we don't have a dog hate my homework scenario. GitHub is very good for making sure that there is no dog hate my homework. Furthermore, if you've not turned in the proposal by the time the progress report is due, right? So this was like April 3rd-ish, okay? Last semester. And then the progress report was like, I think April 26th. So if you hadn't done a proposal by April 26th, then that's the other way to get an Oz zero on the final project because you're too far behind. You're going to be trying. No, you have a week left to do the final project. That's not going to work. I was saying for last semester, April, for spring semester. Mhm. Um, the due date for the final project is hard. The due date will not be altered for any student without prior approval, accommodation, or a sudden and documented emergency or event. Otherwise, it will be due December 9th, I believe. The very last day, the last Monday of classes, right before that done. But yes, you'll be working on this in November. So otherwise, late submissions will be penalized at the rate of a tenth of a point per minute late over the listed due date. So, if you turn it in at 2 a.m. with the due date's 11:59 and you turn in at 2 a.m., that means that your highest score is basically an 88. Having said that, don't be intimidated by the scope. We're far more interested in the journey, not the destination. It's a learning experience, not a tech startup. Mhm. So, um, also, if you're a senior or a junior, I would definitely look at your final projects in your other course and see, oh, is there a way I can use programming in this? In which case, you're allowed to and encouraged to do the same file project in this course in another course you or a group member is taking. The only requirement, and it's actually an academic dishonesty requirement, the only requirement is that you get the emailed consent of both me and the other instructor. So just college 101, it's explicitly against the rules in your student handbook to take an assignment for one class and turn it in for another class, right? You've done this work and now you're turning in for another class, unless of course you get the instructor's permission. And yes, this can be done in any language. Um, so there will be a lot of things. Common issues. How does turning stuff in work? Excellent question. Um, with partners, only one of you needs to turn it in. Just everybody else should link to it. My project is not done and the deadline is upon me. Again, I'm not lenient with any of the other deadlines for one reason I will get into. Um, What if I don't, if my work isn't done? Turn in what you have. You won't get a 0 unless you actually did nothing. I'm interested in what you actually did do. I want to do Hangman? No. Hangman is too easy of a final project. Now there are variations of Hangman I'll suggest if you decide you really want to go with Hangman, like a version of Hangman where uh you um where the computer will cheat and make it so the players can't win. Pac-Man, but he's Mario. Yeah, sure, making a Pac-Man clone or a Mario clone, those are great final projects. Okay. Do have to get approval? Yes. You might decide to do Hangman or something equally trivial. So you have to meet with me so I can give you an appropriate project. The vast majority of the students last semester got a 90 out of 100 on their final project, a 90 or above, I should say. Um, they're the only student, there were only a few students who did very poorly on their final project, and that's because they basically did something like, when you hit this key, I will print out this statement. And there were 4 separate statements. It was something that could have been programmed in 10 seconds. It was no. And it was nothing like what they were proposed. So it was just not good. But this is something where I mean, and when I mean it when I say it, you can get an A for effort on the final project. Okay, an A for effort, where an A is defined as a 90. Okay, so what is your incentive for doing more than the bare minimum? Because I know you guys, I know students, I've been a student. I'm going to do the bare minimum if I can get away with it. The incentive is that I will go through all the sections and I'll select a project from each section, which I consider to be the best of that section. That group will be exempt from taking the final exam. So best projects get to skip the final exam in this class. That's your incentive for doing better. Yeah, sure. Sudoku solver might be fun. Let's see. Now, exams. Exams are timed assessment of your if you need to change your project at the last minute, let me know sooner than the last minute. That being said, the final project's not something to worry about until we're you might want to start thinking about worrying about it at the end of October and then start worrying about it in the abstract in the beginning of November, if that makes sense. You could technically start it today. But yeah, you can think about your final project and your various ideas. Please do. But it's not going to be something that necessarily you need to worry about. For a lot of you who are interested in making video games, this is your chance to learn Unreal or Unity for course credit, essentially. So exams. Exams are timed assessments of the mastery of the material. They will be on paper and in lab, most likely in lab, but I'll need to double check. Exams will most likely occur on week 6. This is week 1. And then on week 10 or 11. Students with accommodation should speak to me to work out the most optimal solution. Usually that's just simply sending it. Yep. So good. So best project equals no final exam. Okay. The due date for exams is hard, right? If you're sick, let me know. But otherwise, when you start an exam, you have X amount of time to turn it in. But I do it in lab typically so students have as much time as possible. Final exams details. Final exam is cumulative. Generally speaking, the way the final exam works is that I generally have 7 questions on the final exam and you choose 5 of them to do. Yep. And yes, the best project from every section is exempt from the final. And if sometimes it's been like, oh, well, I've got I've got a 1-person group and I've got another 2-person group and I can't decide. Sometimes I'll decide, well, maybe I'll let both of them exempt from the final. But again, I guarantee one group from each section will be exempt from the final. Okay. Not all points are equal, just FYI. A point in your assignments only counts for the assignments. A point in the exams is only an exam. Those 2 points are not worth the same amount. All right. So this is also me doing College 101 again for everybody. I've adapted CS50's Harvard CS50 academic honesty policy for this course because a lot of you may not know what amounts for cheating in computer science or academic dishonesty in computer science, intentional or unintentional. Um, I try to be reasonable as possible because I firmly believe that the best way to learn to to learn the material is to teach it to others. Amazing. A teacher would say that the best way to learn something is to teach something. Um, but there's a line between getting help and having somebody else do the work before you. The essence is that basically, if it's not group stuff, you got to do it on your own. Although collaboration's encouraged, so long as somebody else doesn't do the work for you. Generally speak, so this is the rule to keep in mind, okay? Generally speaking, when you ask for help, you can show your code to others when you are the person who needs help. But if you are helping other people, do not show people your solutions. Got it? Make sense? And no, you're actually allowed to work across sections, in which case that group could fall in either section. Okay. Um anyway, generally speaking, when asking for help, if you're the one who needs help, you can show people your code. You can say, I don't know why this code isn't working. Somebody and you can paste that on Discord, and it's great. And that's perfect. That's acceptable. Okay. On the other hand, I don't want somebody else saying, oh, yours isn't working. Well, I don't know why, but here's my code and it works. Mhm. You're allowed to show your code to other people if you are the person needing help. If you are the helper, don't show your code. Okay. So here are some rules of thumb, by the way. If you're having trouble, though, email me. Don't go to Chegg unless you want to fail the course. Don't just ask ChatGPT because ChatGPT is still terrible at doing turtles, and also it will use things that you won't be able to explain when demoing, and then you won't be able to do it on the exam. I mean, you can ask AI for help, just don't expect it to be useful on some because one of the things I use is Turtles, which is a graphical teaching interface. And last I checked, ChatGPT is still terrible at Turtles because it's graphics and it can't see what it's doing there. Right. All right. So what are reasonable things you can do? Communicating with classmates about the assignments or to understand class material. Helping a classmate identify a bug in their code. Sending or showing somebody code you've written, possibly a classmate, so they can help you fix the bug, provided you cite the help. E.g., I worked with Al's Awesome Face. Okay. Again, that's a real hard kind of call to make these days. But the important thing is that you need to be able to learn how to do it yourself because the exams are on paper. So incorporating a few lines of code you find online or elsewhere into your code, provided those lines themselves aren't outright solutions. For instance, looking out how to print out the contents of a dictionary in numerical order on Stack Overflow as part of a larger lab, copying the 1 to 3 lines, and then citing that link is perfectly acceptable. Citations in computer science, by the way, are the simplest citations ever. You just simply make what's called a comment and then provide a link to it. What do I mean that the exam is on paper? I mean, your exams are on paper. It's a computer science class. Your exams are on paper. What, you thought I'd do it on the computer? That doesn't make sense. Why would I make a computer sciences program on a computer? You're programming on paper because of the ability of the again aforementioned ChatGPT issues, but also because you need to be able to learn how to do the code without a computer. No, sorry for. Yeah, you need to be able to write the code. Most programming interviews these days still whiteboard based, meaning that you're expected to write your computer code on a whiteboard. Um, I know that sounds wild, but basically the idea here is that you want to know it's the idea here is that you need is to basically know how to do it. A lot of the first exam will be something along the also it limits the kind of questions I can ask if I do it if I do it on a computer. A lot of the first exam, the questions are along the lines of here's some code. What is the output of this code? And that's not a very challenging question if I ask it on a computer because you could just simply take that and run it and then get the answer. So, especially for that first exam, it makes sense to do it that way. It also, again, especially with ChatGPT and AI these days, there's that limiting. Um, So let me see. I'm running out of time, so you should be able to read through these. But asking it what are not reasonable, getting the solution that somebody else wrote, failing to cite the origins of code or techniques that you discover outside the course's lessons. For instance, copying and pasting the answer from a website. Yes, the syllabus is on Canvas. Giving your or showing a classmate the solution to a problem when it is he or she, not you, who's struggling. Paying somebody else to do the work for you. You can get a tutor, but as long as they're not doing the work for you, that's not the point of a tutor. Paying somebody, there are homework services. I know that you can pay somebody else to do your homework. Don't do that. That is very much academic dishonesty. Um, so I think you kind of get the idea here. When in doubt, ask, and I will show no negative judgment towards you. Okay, especially with the regret clause. If you commit some act that is not reasonable, but bring it to the attention of the instructor or TA within 72 hours, you might get sanctioned locally, like a 0 on the question that you cheated on. Um, but I'm not going to submit an academic dishonesty report. Approximately one student a semester triggers this clause and says, I regretted I cheated and I regretted it. I had a student who said, so last semester I had a student who very remorsefully said, I don't know why I did this. I looked at, I was working on this assignment and I looked at my, sorry, not the assignment, the exam, and I looked at the person's paper next to me to see if I was doing it correctly. And I regretted it. I've been trying to reach you all weekend to say I'm so sorry about it. And what I did is I just had them redo that question with a variation of that question for half credit instead on the exam. Because again, they came forward. Yes, you should start doing the textbooks um, as soon as you can. Again, the textbook will have, you should at least sign up for the textbook. On Thursday, I will be doing will be doing an in-class exercise through the textbook. Okay, syllabus is subject to change. You have rights. Please check out what they are. They're useful. And finally, um, there's a Discord invite here. It's currently untimed and unlimited until at such a time that I need to take it down because somebody inevitably decides it's funny to raid the class Discord. That's not fun for me. It's about the textbook is free. Textbook, click here. Use fall 2024 Rosen. It's free. Yep, you can go ahead and get ahead with your work. Your first lab, if you haven't done it yet, I don't expect you have done it yet. But what you want to do for navigation is go here to the modules where it says start here. You can read about me and my interests here. Module 1 overview. This tells everything you're going to do during this first week. Installing Python. This is the video on how to install Python on your computer. And how to configure idle. And this goes over the textbook. Lab 1 is simply test that Python works on your computer. That's essentially what it is. You're writing a program called Hello World. That's the basic first program you ever write in any programming language. And this lets you know that basically that the programming language is set up and working on your computer. Okay, that's the focus of the lab. So if you've missed lab, reach out to your TA or to me and we can catch you up, but it's also easy enough for you to do on your own. Okay. So that's basically where we are. So that's why it's okay that the first lecture was this first lecture happened after the lab, because again, this first lecture is me going over the syllabus and the way that it works. Um, Also the other bit, which is you're taking a computer science course, and it would probably be really useful at some point that I actually explain what in the world computer science is. Oh yeah, that's a great question. Um, I use idle in the beginning because it comes pre-installed with Python. That's the program I use to write the programs. I use idle in the beginning because it comes pre-installed with Python for Mac and Windows. If you want to use something else, you are more than welcome to use something else. You can use PyCharm, you can use VS Code. I don't care what tool you use to write your programs in. I use idle because the vast majority of students are going to be using idle because that is one less program to have to install for the vast majority of students. All right, so let's go ahead and ask and get into this question of what in the world is computer science? Okay, because you're taking a computer science course, but there's this kind of unfortunate naming issue where basically we think computer science is programming and programming is computer science, and they're very related, but they're not the same. So give me a second to pull up my teaching intro. So I'm just going to go over a little bit of history here. A little bit of history here. Okay. In the small time we have left. Okay. So computer science is kind of a poorly named topic. Computer science is no more about computers than astronomy is about telescopes, biology about microscopes, or chemistry about beakers and test tubes. Science is not about the tools; it's about how we use them and what we find out when we do. Okay, it's not the study of computers, and it is not programming, although it is an understandable misconception because our first exposure to computer science is through programming. Yes, we have two exams. Not a midterm per se, but we have two exams and a final. Computer science isn't about learning programming languages. Various aspects of computer science have existed for centuries, even before we've had programming languages or computers, such as graph theory, even though that's more mathematics. But like, there's this weird cross section where we're not sure where mathematics ends and computer science begins, or maybe computer science. The mathematicians might say computer science is a subdomain of mathematics. Honestly, that's quibbling at this point, but um, and we don't necessarily study specific software. We come up with software to build and we formalize that. Um, I like this debate. I like this this definition over here from a Java textbook. Gibbs and Tucker give the simple definition of that computer science is the study of algorithms. It is the it is the science of automation. It is asking what when we get right down to it, what can be automated? Okay. And that's actually very interesting. And then the other thing it asks is what can be automated efficiently. There's a lot of different areas of computer science. Theoretical computer science, just one branch of computer science, covers a wide variety of topics, including algorithms, data structures, computational complexity, parallel and distributed computation, probabilistic computation, quantum computation, automata theory, information theory, cryptography, program semantics and verification, machine learning, computational biology, computational economics, computational geometry, and computational number theory and algebra. Work in this field is distinguished by its emphasis on mathematical technique and rigor. So yes. So what does it mean that computer science is the study of algorithms? Well, that we'll need to define algorithm in a bit, but so let's actually go ahead and say what in the world is an algorithm before we talk about that. So the algorithm comes from the Latinized name of, and I'm going to butcher this, Muhammad ibn Musa al-Khwarizmi, and his name is it was Latinized to Algorithmy, Persian mathematician, if I recall correctly. Okay, he wrote a textbook, a very famous textbook. So famous you've never even heard it. You've heard it every day, even though you've never heard of it, the textbook before, called The Concise Book of Calculation by Reduction. He wrote it in 820, and we get the word algebra from the title, algeber, meaning reduction. He also wrote a book that contained the formal instructions on how to handle these newfangled uh, base 10 system coming down from India, and how to do these and how to do the operations in this new Indian decimal system, which eventually transformed into our Arabic numeral system that we use today. So that book was eventually translated into Latin centuries later, and that is how that spread throughout Europe. So that is where we get the name out. That is where we get algorithm from. So an algorithm is a set of well-ordered, unambiguous operations that yield some result in a finite amount of time. Okay, so let's go ahead and just parse that, because that's a lot of words all at once. And this is only Tuesday of the first week, and that's a lot. So what does this mean? Well-ordered has a very specific mathematical definition, but think of it in terms of a recipe, right? With a recipe, you have certain directions you need to follow, and you have to follow them in order, right? You need to add the ingredients and stir them up before you put them in the oven, right? You can't just heat for the oven for 20 minutes, then stir it up, and then hope that food comes out, right? No, you don't need to install Python before you get to lab. The point of lab is to install Python. So an algorithm is well ordered, meaning there's a specific series, a specific sequence of events you need to follow. Unambiguous. I hate ambiguity. Computers can't deal with it at all. Okay. This means that the operations, they need to follow some specific direction. They can't be misinterpreted. Operations, things that happen on a computer. This is typically adding or comparing. And then it yields some result, meaning it gives you an answer in a finite amount of time. It does something, and it's going to do it before the universe ends. So, all right, going back over here. Okay. So we study the behavior of algorithms to determine if they're correct. We design and build computer systems that can execute algorithms, and we design programming languages to translate the algorithms into programs so that they can be executed by the computers. So a lot of this class, even though it's programming, what you're doing is that you're taking an algorithm in your head, and you're turning it and you're writing it down in this programming language so that it can actually be made manifest, so it can happen. Are these going to be on the exam? You'll have a practice exam, but the idea here is, so that's an excellent question. On the practice exam, on the exam, I've often asked a question, sorry, on the exam, I often have a question that I simply ask, what is computer science? So there you go. That is the extent of what it's going to be on the exam from this first part. Is coding difficult? I would say question, is coding difficult if you have no prior experience with coding? The coding is difficult whether or not you have experience with coding or not, because you're human. A lot of what makes programming difficult is that you are human and you make mistakes. And a lot of these mistakes are just simply you misreading something or thinking you said something differently than you did. And those mistakes can be extremely demoralizing, and it's hard to know. Um, and it's a mistake and it's something that happens to everybody. You'll see that when you come to me with an issue that you've been trying to solve for 3 hours, I'll be able to solve it in less than 5 minutes. And the reason that is because I've made that mistake about 100 times already, and I've fixed it 1,000 times for all the students I have. But this course is meant to take somebody with no programming experience and turn them into a programmer. And yes, the concept, even though the language will be different, the concepts uh will will be the same. Okay. So what can you do with computer science degrees? Besides being a software engineer, there are a lot of interdisciplinary stuff, which I mentioned because we have a lot of people from biology or neuroscience or chemistry in here. Biology, bioinformatics is big right now. It will never not be big. This is where you use computer science to solve biology problems, such as protein folding, figuring out programs that detect rates of cancer. One of the big uses for AI that's not just generating a bunch of plagiarized nonsense is detecting cancer much earlier than people can. Creating figuring out new drugs such as HIV and HIV inhibitors, prosthetics, new robo arms for people who need new robo parts. It's These are amazingly useful things you can do with computer science that have direct impacts on people's lives. Physics and astronomy. If you're in physics or astronomy, quantum computing, as you may know, is a very big research area right now. Supernova detection, might want to take a look at that if you're into astronomy. Vast majority of supernovas these days are detected automatically using computer programs. And tons of astronomy data needs to be parsed and sifted. Engineering's a big thing. Sorry, has a lot of interaction with computer programming. Business and economics, specifically the banking industry, loves making sure that they have very redundant systems, very secure systems. And if you're on the more high end, and if you like the sound of money, then high speed trading algorithms is where it's at. Oh yeah, COBOL too. Yeah, if you learn old languages that nobody used, that's a good way to make money too. Psychology. There's a whole field dedicated to the cross section of computer science and psychology called human computer interaction. I got my research in that area. My research started in that area by doing user interfaces for blind users, specifically teaching math, helping make programs to help teach kids math when they're visually impaired. Education. So the schedule of the class is follow what's on. I explained at the beginning of the lecture, but follow what's on your schedule. Tuesday, Thursday, and then you have three commitments. You have Tuesday, Thursday, and then you have a lab depending on what section you signed up for. Okay. So in general, though, like software engineering, network, data analysis, security are all big things here. All right, skip forward. Let's go ahead and just talk a bit about history, more history. Okay. So very, very brief history of computer science. Kind of started out with humans being as the computer. In fact, computer was a profession for the longest time. Can we access this on Canvas? I'll have a recording. I think I might have it uploaded. I can double check. But the trust me when I say that that you'll know what's on the exam based on the practice exam. Okay. A very brief history. The abacus basically enabled humans to do better computation by being able to store stuff. Computer science really did not really take off as its own thing until the 1600s to 1800s, when there was a kind of an interest in gear machines. Big machines that would do math automatically that used the position of gears to represent numbers. Pascal, Leibniz, and Babbage, all famous math people, all had different ideas about this, but Babbage in particular is probably the most famous. He wanted to create a gear-based machine which could print the output on paper. Okay, so it would do the computations, it would figure it out, and then it print out on paper what the answer was. Okay, which leads us, and he is famous because of the first programmer, Ada Lovelace. Here's a portrait. Augusta Ada King, Countess of Lovelace, the first programmer, often known as Ada Lovelace. She is the child of Lord Byron, for those of you who did your world literature in high school, after whom the Byronic hero is known for. Very famous. Um, And anyway, long story short, Ada was shunted in an early age to learning mathematics as opposed to going into literature. As a result, she ended up meeting up with Babbage, and she's credited as the first programmer. Um, what it is that Babbage had this analytical engine that he designed but never produced. He was never able to build it. But it would take instructions from a paper card with hole punched in them. Sound mildly familiar to the punch card of old Fortran days. So it would take these instructions on a paper card with holes punched in them. Ada, the reason she is credited as the first programmer is that she translated notes on a paper and sorry, she translated a paper on this, added her own notes to it, she included a program showing how this analytical engine could be used to compute Bernoulli numbers, which are essentially head tail coin flips things from statistics. Um, but also, really importantly, she wrote how a machine, other than how an analytical engine, sorry, a machine similar to the analytical engine might be able to work on things other than numbers, which was about 100 years of its time. She unfortunately died in her early 30s of pancreatic cancer, which a loss for humanity there because who knows what other ideas she could have had. Um, but the other part of computer science that's always been with us is cryptography and cryptanalysis, the art of making and breaking codes, and that's where and modern cryptography started in World War II, where machines were used to break German ciphers. Okay, I will make sure to upload this to Canvas. Okay, um, the German intelligence that was intercepted and analyzed was given the name of Ultra, the keyword of Ultra. Anything from the from the Japanese front was called Magic, and if you had Ultra Magic clearance, then you were pretty important. Um, Alan Turing is basically the other big name in computer science to know. Um, he is often called the father of computing. He His effort in World War II was he worked with a team to build what was called a bomb, a BOMBE, to crack German codes, so that um, basically it's much easier to sink subs when you know where they are, or avoid them entirely when you know where they'll be, and it's easier for your troops not to fall into ambushes when you know where your enemy's waiting for you. Eisenhower said that Ultra was decisive for an Allied victory. I think it shortened the war for about 2 to 3 years. Um, so Turing is also famous for the Church-Turing thesis, which basically says this is what a computer can actually do. This is a formal mathematical model for a computer. Um, he also is known for the Turing test, which is kind of an AI kind of thought experiment for what makes an AI an AI. Um, Unfortunately, like Ada, Turing died way before his time. This time he had the unfortunate how to say luck of being born in a time when being homosexual was not acceptable. He was arrested on charges of being a homosexual, and he was given the choice of jail or chemical castration. He chose the latter and then committed suicide afterwards. So the British government eventually, I think, in the last decade, formally apologized for his death. But that was, again, another case of somebody really early on in computing dying early on. Um, the first computer, there really is no kind of first. It's a lot of contentious. There's a lot of people who want to claim to have the first computer. A famous early computer is ENIAC. The electronic numerical integrator and computer construction began in 1943, completed in 1946, used vacuum tubes, 1,800 square feet, and primarily used for artillery calculations. Okay. In fact, and these were big, and the vacuum tubes were big. In fact, the term bug comes from possibly the last figure who I recommend knowing about. It comes from Grace Hopper. Um, Rear Admiral Grace Hopper. She was a computer scientist and mathematician, and she um, found and there was an issue with the computer, and she found a literal bug in the computer that was causing a fritz. Legend has it this is where we call why we have a why we call this a bug. We will be ending shortly. Um, the um, and as you well know, first, the main thing about computers these days is that they have become smaller and more efficient, and they've become more interconnected. Okay, so we are about out. Um, so we're about done. So my last piece of advice is practice. You want to be able to do more so you can do less later on. Um, so again, if you missed your first lab, reach out to me. We'll see if we can't squeeze you into another lab. Um, your first assignment for Hello World is very simple. You look up a famous computer scientist. I recommend Googling the term famous computer scientist, and you'll write a program to print out 3 facts about this scientist. The second thing you'll want to, and then the second part of it is some fun drawing. Okay, we're using text, but the important thing is just simply getting the entire point of the first week is just simply getting Python installed on your computer. That's it. All right. With that, class is dismissed. I'm going to go and get some water for myself, but I will hang around to handle any questions that students may have. All right. And I look forward to seeing you all in person.
Thank you.